Hello. Welcome to another module. We are almost halfway through this class. Seems hard to believe it's gone sort of fast. Um, so yeah, happy March. It's March. The snow's melting. Looking okay in some ways. Anyway, thanks for joining in. I'll wait a minute or so for if anybody else wants to catch up here. Today we're just going to be, as usual, first day of the module, we'll be going through the unit, talking about what we're going to be doing this next couple weeks. And then I'm going to look at the lab first, which is just a virtual lab. I know this week you're going to be doing your at-home experiments that you've proposed, or this week and next week. So that will be kind of your hands-on part, and then the other part will be a virtual lab. So not as exciting as something to do hands-on, but you have your own stuff to do hands-on. I've gone through, I believe, all of the submitted proposals for your at-home experiment. So check your grades on that, and as long as you have, most or all of the points and a note from me saying go ahead and do it, you can go ahead and do it whenever. I've also graded your labs from last time, so make sure to check the comments there. Most of the time, you all did a great job. The one thing that I had to say several times was just that to make sure that you are keeping a good lab notebook. So make sure you're really writing down all the observations, all the things that you're seeing, all the things that you observe in the course of your experiment. It's not just about taking the data, and it's really about monitoring that whole process of the experiment and writing down everything that you see. So this time around, make sure that you do that. Okay. It is after 7, so let's take a look at the module. So on Blackboard, you can see the summary behind me. We're going to look at ions this week, as well as macronutrient structures, proteins, carbohydrates, and lipids. We're also going to learn about graphing. So that's really the 3 main ideas this week. To do that, we'll be, as usual, meeting here Monday evenings and Friday mornings, where you're welcome to ask your questions or just watch to complete your stuff later. There's a couple things to read on ions and macronutrients, and somebody asked about practice material, so we'll probably put something up for that as well before the quiz, before the 3rd quiz, which will be at the end of next week. All right. That's pretty much all the stuff to do. And then the article report. The 4th article report is this week. This will be the final article report of the semester. We're going to be changing gears a little bit next time to start looking at the scientific literature and kind of get away from the popular literature. So that will be a little bit different what that assignment is from the article reports that you've been doing. But the other ones have all looked great, so I assume that you know how to do this, and the 4th one will be fine as well. Okay, let's take a look then at the graphing lab. All right, so I've got it here. Now, graphing is probably something you've done in some fashion before. Depending on your background and the other classes you're taking, you may have done a lot of graphing, and this may be a completely redundant exercise, but if that's the case, it should at least be fairly quick and easy. So if you haven't done this kind of stuff before, it's really important, not just for science. This is a class for non-science majors. Throughout your life, you're going to want to express data in graphical form, probably many times. So having some good facility with graphing software and understanding the different parts of a graph and how to make a good graph, line of best fit, all that stuff is important. And if you haven't done it for a while, it's a good chance to get back into that. If you have done it, it's just a good chance to, just check your work and make sure that you're doing it properly. All right. So a few things about design. Now, in the communication of scientific data, we have a couple considerations. So one, as we'll get into in the next module, when you look at scientific journal articles, the published data, They are very dense, and I don't mean like they're hard to understand, although they're often that too. I mean they're like there's a lot of words on the page. They're trying to squeeze as much in, and this kind of comes from the old like publishing something as an actual physical book. You can't waste space because you got to print all that stuff and print it out and send it to people. So you got to be economical with space. So most scientific figures are small and want to communicate the most information in the least amount of area possible. So that's why in some papers, and we'll look at some of these, we often don't see things like bar graphs and pie charts because they don't communicate that much data, but they take up a lot of space. So if you look at the bar graph on the left, a bar graph on the left here, that's essentially reporting 5 pairs of numbers, a month and a number of students. And yet it takes up all this area just so you can see these bars. It doesn't even really vary that much. Same thing with a pie chart. A pie chart is not reporting that much data, but in its visual form can be really useful. And you can make a pie chart pretty small and still have it communicate the information. But the most direct way to communicate information in this way is with a scatter plot. So when you have the individual points, like maybe you did on graph paper in math class or something someday, that's the best way to do it because it takes up the least amount of ink. It's very clear what's going on, and you're reporting the actual data as well as the trends in a way that is easy to interpret. So you can read some of these other rules here as you're preparing those graphs. As you prepare your graphs for this unit, make sure that your graphs do indeed follow these essential rules. So when we're talking about the intervals, don't necessarily just use the default range that the software gives you. Make sure you format it in a way that makes sense and that gives you the best possible graph. And this is especially true if you haven't done this kind of thing before. If you know how to use the software well, show me that you can use it, and then you can make a nice graph. And if you don't, ask for help. I'd be happy to help you with it. So for this one, since it's a lab, there's a pre-lab assignment kind of before you would come into lab, and then we would actually be doing these measurements in lab if we were in person, but we've kind of adapted it to a virtual format. So you can just do these whenever. You can do them before the lab. You can do them as you're doing the lab, whatever. It just becomes part of what you put in your notebook. So that's fine. All right. So in this case, we're going to look at some density. Now I'm going to show you this particular simulation. Now the simulation that's linked here allows you to measure density by water displacement. And what I found when I was trying it out is that it didn't work on all of my browsers. So if you're having trouble getting it to work, it should look like this. If it looks like this, it's working. But like for me, it didn't work on, I don't remember, one of them, Firefox or Chrome or something. And it did work on another one. Right now it's in Microsoft Edge. So if you've got a device that can run multiple different browsers, you'll try the different browsers and see what you get. If something's not coming up in, let's say, Safari, try to get Chrome or Firefox or Edge, or I'm sure there's even other ones out there. But you should eventually get something that looks like this. And you're just going to go to the intro, and this is what it looks like. So what you do is you pick the material that you want. And the instructions, the way they were written in our lab, are a little bit confusing, but you want to just pick the ice. So we're just going to pick ice. All right, so we've got our nice block of ice here. And we can pick the mass. And notice that as we change the mass, the size of the ice changes as well. So we can look at some different masses and volumes based on the density, and the density of the ice is given there as well. But what we're going to do is we want to find the density from the actual data here. So what we can do is, oh, I see. The instructions say to make it custom, but we're going to make it custom. No, that's not going to work. Let's just stick with the ice. Stick with ice. So what you see here is if we take it out, you'll notice that we've got 100 liters of water in this tank. And we drop it in, and ice, the density of ice is a little bit less than water, so it floats with a little bit sticking out on top. So in order to find the volume, we actually have to submerge this entirely. And so submerging this entirely shows us that the volume is 107.18 liters. And so the overall density is the difference between what happens when it's out versus what happens when it's in, which is 7.18 liters, which is what the volume says over here. So you're just going to write down some different mass volume pairs. I think it says to take about 5 measurements, and that's it. So then we're going to graph it. All right, now I'm not going to graph this along with you right now, but I do want to show you the tool. So this is one of the free ones that's listed there, mycurvefit.com, which should allow you to make a decent graph. If you want to use more common software like Excel or Google Sheets, that should work fine for this as well. All right, so here all you do is you put in your data here. You can put in your axis titles, and then you're going to pick fit method, and we want a linear regression, regular straight line, and that's what we'll use to determine the density. Now, one thing that is important about density is, in this case, oh yeah, and there's also some help. Let me move this back. So that's the sites. If we go back to the instructions here, you can see there's even some videos that show you how to do this, how to graph, and the Harper Chemistry Club put that together. So you may see some fellow students in there on how to generate a calibration curve in Excel if you have that one, or you're welcome to use one of these other ones. Anyway, that you can get the graph and get the line of best fit. So one important thing about density to know for graphing, the density of water is 1 gram per milliliter, which means 1 gram of water, liquid water, weighs or takes up 1 milliliter of space. Density is a ratio between a mass and a volume. So that means that when the when you are plotting your graph and thinking about your line of best fit, you can kind of think about what seems reasonable. And we already said ice has a lower density than water. So when you look at that curve and you look at those results of what you've gotten, hopefully that kind of makes sense. All right. So when you've got that, you should submit the scans from your notebook, or if you want to type all this out instead of putting it in your notebook, since it's a virtual lab anyway, that's totally fine. You can do that. Just keep it all on the computer and not worry about scanning things. And just include your graph, the answers to the questions, and this claim and evidence. Well, these are the questions here. Right? And so the part that's going to be a little bit confusing here is just that we used ice, but we're saying for the purposes of this experiment that we did not have ice, that it was actually a piece of plastic, even though we're using the data for ice. So then you can compare and see which plastic you think it was based on the density. And in fact, density can be a good way of separating things. So some of you did density columns for your at-home experiments where you layer different density liquids and solids, and you can see how they separate out. And when we have our mixed recycling, like when we throw all of our stuff in our recycling bins together, one of the ways that gets sorted is by density, so that the more dense things can be separated from the less dense things, and that helps to separate different types of plastic from each other. So you'll be kind of doing part of that as this lab. All right, so that's all of the stuff from me right now. I will get to work on grading your stuff that you just turned in on Friday. And I'm excited to see your at-home experiments again. You did a nice job on that before. Last thing, since we've got some time here, what do you do if you still have missing assignments? So missing assignments in Blackboard, after some time, they get a 0 because otherwise they don't get calculated into your total and you don't really have a good sense of your grade. If you have some zeros in Blackboard and you want to catch up on that stuff, you can get it done right away and let me know. I want to give you points for work that you do, especially if I'm missing something or if like I just overlooked something. Make sure you check those grades and let me know. Once the middle of the course comes around, which is going to be the end of next week, that's when stuff that's not done is really going to be kind of piling up and hard to catch up on. So if you have missing stuff, please try to get it done by the end of this module. This is a fairly light module in terms of the workload, so you should have time to catch up on stuff if you need to. But try to get that done by the end of next week. And then if you do catch up on stuff and you submit some of those overdue assignments, let me know, because to me on Blackboard, I don't see that you've put in new stuff once it's a 0. So if there's something that's 0 in there because you didn't do it, and then you do it and you submit it, tell me so that I know. Send me a message on Discord or an email or something, and then I will know that there's something there. I can look for it and I can grade it. All right. Most of you are doing a great job keeping up with everything. I know the last module was tough with the structure drawing, especially was tricky, as well as the boiling points. I believe I have it set so that you can look at the answers now on that quiz, last week's quiz. So please look at your answers and see what you got right and wrong. And we will go through it maybe on Friday this week. I'll go through all the answers and make sure you kind of know what's going on there, because it was a tough quiz. I know that material was new for a lot of people and difficult. But I want you to learn it. I want you to know that stuff. So let me know if you need help. And yeah, let me know if you need anything else. I don't see any questions in the chat or on Discord. Check again. So I guess I will say good night, and I will see you Friday morning. So bye, everybody.